Welcome back. Welcome back. This is part 3 of structural design patterns. Now I did cover the adapter, the composite, the adapter, the bridge, and then now we're going to go through decorator a little bit, the flyweight, the proxy, and the facade design pattern to finish up the structural design patterns. Again, structural design patterns, these are actually related to object organization. Let's start looking at the decorator, something that you've done, and we've talked about a lot in the context of Lexi and even as an introduction to the class, and you have used it in your assignments. Nevertheless, again, the decorator, just like the bridge, can be used in an inheritance solution or at the class solution, or using inheritance, but it's inflexible. It takes and maintains the code in different layers. I'll show you an example, but instead we're going to use it at a decorator. We'll have the concept of a transparent enclosure, basically where an object is, the embellishments is transparently added to the object. So you can get a core class or core objects, or you can get a decorated or an embellished object. And we've seen this in the case of Lexi. Remember, when I showed you the scroll bars, these are embellishments that get dynamically, okay? And also the border besides the scroll bars. You see here we have two decorations, 1 and 2, and then we have the basic object. Remember when we saw the car example, for example, we have a basic car and then we have a sports car. The basic car is always there. Now, whether to transparently add the additional embellishments or not is the job of the decorator design pattern. What is the structure? Here's the structure for the pattern itself. Looks very familiar. Basically, we have a component, got some concrete components, and we have the decorator, and we have the actual implementation of the decoration. So this would be, for example, a sports car. This could be a sports car. This could be a truck, and this would be a basic car. Okay, and this operation could be the drive. So if you want a basic car, you get this guy. If you want a decorated car, then you get a decorator. You pass to it the concrete, basically, class. That's what this basically means here in using a has a relationship, how you can actually do this. Let me take an example. And the example, well, let's look at this one where we have a window, a visual component, which could be a text view, or which is what you saw here. This is a text view right here, a text view object all the way at the bottom. And then so these are the methods for the abstract class that needs to be implemented: draw, resize, and the actual constructor. And then we have the decorator, which extends the visual components. Okay, so it maintains this component object reference to the actual component or the actual object, the basic object, the concrete object, the core object, that without any decorations. And then we'll add actually some decorations when need be. Notice that the decorator can basically draw the component first, which is this one, and then it can operate on it. It can, resize it. It can add a scroll bar and so forth. Okay. Now let's look at the draw method. Then again, we use the decorator to draw, to get this basic view, and then we draw a border. And if I want to draw a scroll bars, I can draw scroll bars, and then and so forth. Okay. In other words, this guy encompasses this by. That's what this means. Composition relationship, and it adds additional stuff to it. So inserting this here, and it needs to be transparent. That's what transparent enclosure means, because sometimes we don't want the client, by the way, works at this level. They just call it draw. If it's a text view without any embellishments, this would be drawn. If they need embellishments, they would have to pass the decorator object reference. Okay, sorry, this was the other video. The decorator object reference. Okay. Another example for you to go through in the Java library, this is the concept of a stream. And here's another example of a, let me walk you through this example. Actually simplifies life. Let's say we have a computer. In the computer we have a method called description, and it says you are getting a computer. And if I wanted a change the description, I want to say you're getting a computer and a hard drive, then I would have to change the description method and so forth. So we have computer description, new word description. If I want to add additional stuff to the computer, then I would add a new worry description, a fourth version, and so forth. So that's the problems that the decorator design pattern can basically solve. We can get the basic, and then these additional stuff are embellishments that we can have. So this is a good view, and if you of the decorator pattern, if you are familiar with the Java input-output framework, it looks exactly like this. System.in works here. Then we have the input stream, and then the buffer stream where it takes characters and buffer them, and so forth. The same exact, and that is an implementation of the decorator design pattern. So let's start by defining the component decorator itself, which extends computer, like was outlined in the structure earlier, and it has, notice it's an abstract class, it has a method that's called description. And then we have a disk, which extends the decorator. And then notice that now it's going to call the description of the core object without any decoration and adds the decoration. This is basically the decoration this class provides. And then we have a CD. It's going to get this and a CD. Now, again, this could be multiple layers, multiple wrappers around each other. I'll show you an example in a minute. And here's a monitor. And what also I forgot to outline, that in the constructor of these subclasses, they take an object reference to the core class. Okay, an object reference to this guy. And the structure, an object to this guy. Okay, which is basically what we want is this operation. Basically, we can invoke this operation. This is what this says using the S object reference that we have talked about here. Okay, notice all of these methods, they take an object reference to a basic computer object. I think I have done a class diagram for this. I don't know where it is. Okay, I'll try to insert it later. You're getting a website here, and here's the test class. Notice we create the computer object, then computer object equals new disk, we pass the computer object. New monitor, we pass the same object. If it has already disk decoration, it will have a monitor decoration and a CD decoration, and maybe multiple CD decoration if I want two types of CDs, and so forth. Another example is a website. I'm not gonna go through the code, but it's the same hierarchy, the same idea how the decorator can be useful. Let's jump into the facade, which facade means wall. Basically, simply said, the facade works like this. We have multiple subsystems in our application. We don't want everybody to tap to it from the outside. This is what this picture here says. This could be a client 1, client 2, client 3, and they're all getting into the nitty-gritty details. It makes spaghetti code. It makes it ugly. If I do a change here, I have to notify everybody here. So that's the problem we're trying to solve with the facade pattern. So we provide an interface to our systems. The clients can simply work with the interface. It is very useful, for example, if you're building a compiler, because there are many subsystems to the compiler system, and you can basically, people can just say compile, and then we will do all what we need, tokenization, parsing, and syntax checking, and all that good stuff. Good picture of the structure in your textbook that you see here. Facade has access to our actual concrete classes and interfaces and so forth. I think I've built many facades in my life, but let me show you this facade today. It was an Enterprise Java Beans application, AJB. And here what I gave is this facade. It's called facade session. By the way, facade is all over Java. And then I provided all of these methods that makes up, I think this was an ad server that makes up the core of the ad server that I had back then, about 10-15 years ago. Okay, and let's talk about the proxy. which is simply said, a proxy is a replacement, is a lightweight object that replaces a heavyweight object. For example, if you're downloading a big image, the big image, it takes too long to download it, so we replace it with a proxy and then image. That basically barbershop or whatever icon, the circle that goes around the GIF image. That's not just a simple image, it also has information about the actual image. It knows how to draw, it knows it's, so in other words, it has an object reference to the actual image. Okay, here's how you understand this structure, and also pay attention to what's in memory and what's on disk. This image is actually on disk. Here's my Microsoft Word. I needed a huge image. I get a proxy. The proxy has information about the actual image. When the document is ready for it to load that image in memory, it calls the proxy. The proxy gets the image and load it back into memory. Here is another what's called a multiplication, a depiction of the image example. These are things that we could be doing to an image. Here's the actual image, and here's the actual image proxy. Notice the proxy has all of the methods of the image. So it's a shadow of the actual image. It's just a lightweight. I don't actually have the actual image itself, and that's when I call load image method to get the actual image when need be. Okay, when need be. And here is the formal structure. We use the concept of a subject, a real subject, and a proxy. The proxy is a replacement for the real subject. Okay, and the real subject object reference is maintained in the proxy, and it will be requested when the client, and in most cases it's the text editor, is actually ready for it. Okay, this is just simple information about the proxy. It's used in Java in the list. A student, you can have a proxy for any type of an object, basically. Here's an example. I think I've showed you this before, but for proxies are used a lot in servers. So you got the idea. Just a stand and a replacement for an actual heavy object. A flyweight, which is interesting. It's kind of trick what a flyweight is, but let me explain in an example and in the context of a structure of the flyweight design pattern. Flyweight simply said, in the text editor, for example, the letter A, notice, let's see how many A's we have. Actually, it's here. Yes, in different configuration, but they're all the same A. So if I were to, since everything is an object in Lexi, then we would have to create, at least for this slide, at least from what I see here, is that many A's, 1, 2, 3, 4, 10 objects of type that are all the same thing. Sometimes it's capitalized. That's called a entrytic information, and sometimes it's the actual letter itself. I'm sorry, extrinsic state, which basically the formats, capitalization, the font, and we would have an intrinsic state, which is the actual letter A, and then capitalized, or A bold, or A red. This way I can have all of this information is maintained in the object itself. So the flyweight says, instead of having 10 objects, have one object, and then have the object shared in this fashion. Right, have the object shared among all locations that it needs. For example, let's look at this column and row idea, which is, by the way, stated here in this diagram. We have a glyph, we have a row, we have a column, and we have the actual character. We have this intersect method to know where the character actually exists on the page. And then the row needs all of these letters, A, P, P, A. So, for example, P is repeated twice. So instead of having 2 PP objects, we have a pool of objects that exist here. You see that? And these are all singleton objects. These are all singleton objects. And then whenever a P is needed, it's referenced from this singleton. You call it. If it's there, return it. If it doesn't, you create it, just like we have done in the singleton class. So main goal for the flyweight design pattern is basically performance. I don't want to load hundreds of thousands of characters into memory. Okay. Another example that I thought useful is not necessarily many objects. You could also have a little objects, but they're heavy objects. So for example, if my application, it's the same object, but it's heavy, object 1, object 2, object 3, object 4, and then my code is trying to access all these heavy objects, what I would do, I will put a flyweight singleton in the middle, and then play with the configuration. But it's one object, but I change the configuration to make it look like it's many objects. Here's a good example of a student. So I'm going to find the average of all students at IIT. I'm going to see how we're going to do this using the flyweight. This is simply student class. There's nothing interesting here. Setters and getters and instant variables. Okay? And get standing method returns something. It doesn't matter what it is. Here's where the magic happens. In the main method, the test class, let's create, as an example, 3 names array, 3 scores arrays, and 3 IDs arrays. And then basically, whatever here we're doing, we're trying to find the total for every score for every student. And here's the magic of the flyweight. We can create one object, which is called a student in this case, and then loop using the same object, take different information from these arrays. For example, in the first iteration, we'll take Ralph 100145 and as name, ID, and score. In iteration number 1, I becomes 1. So the loop index becomes 1. So we take Alice and then. Imagine this has 100,000 records. Then we will only be using one and only one student object. But what we've done, we changed the configuration of the object to look differently. But it's actually, they're different objects, but we are only loading one object in memory at any point in time. And that is the beauty and the benefit of the flyweight design pattern. Next week, I will cover behavior patterns. Thank you. Come again.